Unit 7, Part 2 notes. I can graph a parabola by plotting the special points. Just a reminder of our key pieces of information for a parabola. A parabola is a U-shaped graph created by a quadratic function. New piece of information is right here. This is what we call standard form of a quadratic function. So y equals ax squared plus bx plus c. We've worked with this form before with polynomials and factoring polynomials. So we are reusing this form when we are doing quadratic functions. And then we have our axis of symmetry. So that axis of symmetry splits that graph in half. We've identified that. And now we are going to calculate that using an equation. The equation for that is x equals the opposite of b over 2a. So you have your b and your a. We're going to use those numbers to calculate that axis of symmetry. And then vertex is still that highest or lowest point. All right, and then we still have our x-intercepts. Those are where we touch that x-axis right there. They are also factors of the quadratic. So if we were to go back to what we learned in Unit 6 about factoring and factor our quadratic, that would give us our x-intercepts. And then the y-intercept is where we touch that y-axis. And that one is really nice. It's just 0, c. So in our standard form, whatever this c value is going to be the y-intercept, which is very handy when identifying that. So now for today's lesson, you are going to be given a quadratic function in standard form, which you can see right here. And we are going to identify the key pieces of information and then graph it. So unlike last lesson where we received the graph to identify the information, we are now going to need to identify the information in order to graph the function. So the first step is always to identify your a, your b, and your c. So in this equation, a is always next to x squared. So in this case, there's no number there, which makes it a 1. B is next to x, which is -8, and then c is the number with no variable next to it, which is 12. All right, so now we are going to use our a and our b to solve for our axis of symmetry. So we have x equals the opposite of b. So I did set up some boxes for you to type in, which will make it nice and easy if you are doing this digitally. So we have negative, and then we are going to want to put our b value in there, so the -8. And then on the bottom, we want 2, and then in parentheses, we are going to put our a value, 1. So now on the top, you can see we have -8. So the opposite of -8, or that double negative. So the opposite of -8 would be a +8, or a double negative becomes a positive. So we have 8 remaining on the top. And then this 2 in parentheses 1, that just means 2 times 1. So we're going to do 2 times 1, which is 2. And now we are left with the fraction 8 over 2. So 8 over 2 really just means 8 divided by 2. We're going to do that division. So 8 divided by 2 gives us 4. If you are not the most confident in your operations, you can also use your calculator. You can set it up right away as a fraction, do that -8, and then 2 times 1 on the bottom, and it'll do all the math for you. So whichever way you choose to do is fine, but please make sure you are checking your work there and making sure that that number is correct. All right, so now that we know our axis of symmetry is at 4, I'm going to take my dotted line. I'm going to drag it over to where x would be 4. So the 4th line after the y-axis. Now I am going to solve for my vertex. Now remember, the vertex always lies on the axis of symmetry. So the axis of symmetry is going to help us find our vertex because this 4 is going to be the x number of our vertex. We know that number is the same. We saw that last lesson. So now that we know our vertex has the value of x is 4, we can take our equation and replace x with 4 to solve for y. So we're going to take our equation that we were given, our quadratic, and instead of putting x, we're going to put 4 each time we see x. And then we are going to solve for y. Now again, we can do the math step by step, or we can go ahead and use our calculator. So if we use our calculator, we're going to do 4 squared minus 8 times 4 plus 12, and then our answer we see is -4. So when we replace x with 4, we get y is -4, which then gives us our vertex is 4, -4. So I'm going to plot that point on my graph, 4, -4. Now the next piece of information we will identify is our y-intercept. Now remember, y-intercept is always 0, c. So it's always going to be that c value right there, so it's going to be 0, 12. So I'm going to take this little blue dot and I'm going to bring it to 12 on my y-axis, which is all the way at the top. Now the last part is going to be creating a table. So this is why I wanted you guys to pay attention to the symmetry in part 1, because the symmetry is going to really help us create this table. So we're going to put the vertex in the middle. We're going to do 4, -4 right in the middle, because we already know that information right there. And then we're just going to complete the x values on the table by doing 2 smaller than 4, so 3 and 2. And then 2 bigger, 5 and 6. So then they go from least to greatest, top to bottom. Now we are going to use our calculator just the same way that we solved for the vertex. We are going to replace our x values with 3 and with 2. So when I replace my x value with 3, I can just replace this 4 here with 3. I'll put it in parentheses so we remember that that one's the x value. And then I can replace this 4 as well with 3. And I get -3. So when the x value is 3, the y value is -3. Now knowing symmetry, that is going to be the same for 5. That -3 value is going to be the same here and here. So that symmetry is just going to help us complete those table values, which is going to allow us less time calculating equations. So then I'm going to do the same thing. I'm going to replace my x value with 2 in my calculator, and I get 0. So when x is 2, y is 0, and also when x is 6, y is 0, because again, that symmetry is going to dictate that those values are the same. So now I'm going to plot those points. So we have 3, -3, and then 5, -3. The symmetry also helps when graphing because it makes it nice and easy to locate those symmetrical points. So 2, 0, and 6, 0. And then we can arrange that parabola into the points, make it line up all nice and pretty, as best as you can. It might not fit perfectly, but just try the best that you can to get it to line up with the points. And if you're doing it on paper, you can just hand draw it all. All right, so that is how you are going to do your practice for today. We're going to go through one more example together, and then you will have problems to try on your own. All right, so here we have y equals negative 2x squared plus 4x plus 5. So again, we're going to start by identifying our a, our b, and our c. And then we are going to solve for that axis of symmetry. So we are going to do the opposite of b. So b is 4. And then on the bottom, we're going to have 2, and then times our a value. Opposite of 4 is just going to give us negative 4 on the top. 2 times negative 2 is negative 4. And then negative 4 divided by negative 4 is positive 1. So our axis of symmetry is x equals 1. So I can drag my line over there, x equals 1. And now I'm going to use that axis of symmetry, that x equals 1, to help me solve for my vertex. I'm going to replace x with 1, and I'm going to solve for y. So if I replace x with 1, I can put a 1 here where x would be, a 1 here where x would be. And again, you can feel free to use your calculator. So I'm going to type in my equation, negative 2 times my x value of 1 squared plus 4 times my x value of 1 plus 5. And that gives me a y value of 7. So I can say that y is 7. When x is 1, that makes my vertex 1, 7. So I'm going to take that orange point and plot 1, 7. And now we're going to solve for our y-intercept. So remember, our y-intercept is always 0, c. So c is 5, so we can just replace that c with 5. So we know our y-intercept is 0, 5, so I can put this right here at 5. And now remember that last step is to create a table. So we're going to start by putting our vertex in the middle, which is 1, 7, right there. And then again, putting 2 smaller numbers above 1, 2 bigger numbers below 1. Now, in this case, what we do have is we also have 0 coming up in our table, and we know that when x is 0, y is 5. So I already have 3 values in my table because that symmetry gives me the third value. So I already have that point plotted for 0, 5. It's going to end up being my y-intercept, so it's going to be that blue one. And now we can plot that 2, 5 on the other side, so right there. And then lastly, we just need to solve for when x is negative 1. So again, I can use my calculator. I can replace my x value with negative 1. And when x is negative 1, y is also negative 1. So we have negative 1, negative 1. And then symmetry would say that when 3 is plugged in, it will also be negative 1. So now we can plot those points. And the last step is to then graph the parabola. So in this case, it is opening down. And we can make that parabola fit the best that we can. Again, if you are doing this on paper, you can just hand draw it. You don't have to try to match this up. So one thing to note is that this a value here does dictate if the parabola is opening up or down. So in this case, since our a value is negative, it makes that an opening down parabola. But in our first example, our a value was positive, and that parabola opened up. So that A value is that deciding factor of if the parabola opens up or opens down. All right, I apologize for the longer video, but I hope it was really helpful for you. So now you have your practice. It's just 7 problems that are exactly the same. So just to practice graphing those quadratic functions. If you have any questions, please let me know. And then remember, once you are done with your practice, please be sure to complete the check-in on Schoology.